Hello, I'm Joshua, and today I'm going to talk about the solar system and its origin. Have you ever wondered how the home planet we call Earth and the solar system we live in get the shape it is now? Scientist Immanuel Kant proposed that all stars in the solar system are formed in a similar process. It's called the nebula theory. At first, the solar system is just a giant cloud of gas and dust. When a nearby supernova exploded, shock waves triggered a chain reaction in that cloud of gas, and it collapsed due to gravity. In the middle of the collapsing cloud is the birthplace of our Sun. When gravity increased around the center, mass accumulated. And in order to keep the angular momentum, the gas and dust surrounding it started to spin faster and flatten into a disk. Density around the center core increases, trapping radiation and turning it into heat. And when that temperature is high enough, there's a spark. H fission started, and that marks the beginning of our Sun. Meanwhile, when the Sun is in its formation process, other gas and dust in the disk also start creating something beautiful, planets. As you know from simple physics, different elements condense at different temperature, such as gases condense at lower temperature, metal and rocks condense at higher temperature. When the rocks and metal sticks together due to the electrostatic force and grows larger, it forms planetesimals. Due to the bigger size of planetesimals, it starts to have gravitational pull on other objects and matters. It even starts to attract other planetesimals. And these planetesimals start to stick together, and when they get large enough, they form a planet and turn into a spherical shape. There are two categories of planets in our solar system. One is the terrestrial planet, which I'm going to talk about first. There are 4 terrestrial planets in our solar system: Venus, Mercury, Earth, and Mars. They all have similar characteristics, like hard solid surface, metallic core surrounded by mantle, mountains and volcanoes depending on tectonic activities. Some even have atmospheres, like Venus and Earth. On the other hand, we have 4 Jovian planets in our solar system: 2 gas giants, Jupiter and Saturn, and 2 ice giants, Uranus and Neptune. Since they are all located beyond the frost line, they are composed mainly of gas condensed, and a varying degree of other heavier elements. They also have distinct cloud layers due to the gases condensed into liquid or solid state. But how do we know what happened when the solar system was formed billions of years ago? Scientists proposed the nebula theory by observing the universe around us and collect samples that originate outside of Earth. When we look at the night sky, we're actually looking at history and examples similar to our solar system, like dying stars, supernova, nebula, and formation of new stars. For example, the Orion Nebula suggests a protoplanetary system. All these help us theorize the event that shaped our solar system. Also, there are numerous samples we can study to know more about the early solar system, like the samples collected from meteorites that provides evidence that there was a supernova nearby, the Apollo missions that collected moon rocks, the Stardust mission that collected comet dust, which is potentially going to show us what the young solar system is going to look like. However, the nebula theory still has its flaws, and that some of the observations in our solar system cannot be explained by it. For example, the mystery of planetesimals, whether or not it's true, the rotational speed of the Sun, which should be a lot faster. And some argue that 4.6 billion years is too little time to form large planets. And the occurrence of extrasolar planets that contradicts predictions by scientists. The universe contains endless possibilities, and the formation of our home solar system is somewhat still a mystery to us. Hopefully, we will learn more about our origin in the future. Thank you.